Okay, we are on to example 3. Again, we look back at our chart and we see which one it looks like. We have the x squared first and then a number. There's a minus, so we're using this bottom one here. First thing that we need to do is figure out what our a is. This 7 right here is a squared. So to get the a by itself, we have to take the square root. So our a is the square root of x. Then from there, we can define our x as a secant theta. So we're going to have x equal to the square root of 7 secant theta. We have our x, we take the derivative, and then we can go from there, okay? So now, instead of x, we are now writing the square root of 7 secant theta. So then on the bottom, we have the square root of 7 secant theta squared minus 7. And then our dx now becomes this. So we've rewritten the entire integral in terms of theta, okay? And now we need to do some simplifying. All right, so first thing that I did is I took this square root of 7 and this square root of 7, multiplied them together, and I got just a whole 7, right? And then we have one secant here and one secant here, so we get secant squared. And then we have a tangent, okay? So that's where the top comes from. On the bottom, this part is being squared, so that's going to be the square root of 7 times square root of 7, which is just regular 7, and then secant times secant, which is secant squared, okay? And then minus 7. Remember, pluses and minuses separate your parts. On the bottom, we have two parts. Our goal is to get these trig functions by themselves, and there's a 7 connected in the front here, so we're going to have to pull that out, okay? So we're going to factor out a 7, and when we factor out that 7, it's going to look like this, right? And then we can pull this square root of 7 out to the front, okay? To the front in its own radical, okay? So we have the square root of 7 and the square root of secant squared theta minus 1. All right, now from here, we go back to our section 7.2, which we previously learned, and we look at what we have. We either have even secant or we have odd tangent. We do have an even secant, so we can see if that works. If it doesn't, just go to the next one. In this case, it did work, so we're working with tangent, or secant squared theta is equal to 1 minus tangent squared theta, and our u is going to be tangent. So if we let our u be tangent, we get the derivative of u to be secant squared theta du. And then this is the information that's coming from our box, okay? So now let's start plugging stuff in. So we have the square root of 7, that's just the scalar, so I'm going to bring it out to the front. And then u is equal to tangent, so I can change this tangent to a u. And then our du, remember we always have to have that du out by itself. So our du is going to be secant squared theta, so that becomes du. And then on the bottom, secant squared minus 1. So this is one where it's not going to be the exact form. So y'all see that? So this is, you were given or told in our problem that we have secant squared minus 1, but we know that secant is equal to this. So essentially we just subtract 1 on both sides, and then we get secant theta minus 1 is equal to tangent squared theta. Does that make sense? So now this red line right here is actually equal to tangent squared, but we're changing everything in terms of u. So instead of tangent squared, we're going to have u squared. So instead of 1 tangent, we have 2 tangents, and so that's why we have u squared, okay? And that u squared is still underneath the radical, and those radicals cancel each other out, which leaves us with the u, and then we have a u. So this radical cancels with this squared, and then we're just left with u, right? And then u over u is just a 1. Easy to take the integral, that just leaves us with the letter. So we're with respect to u right now, so it's going to give us u plus c. So remember, our goal was to originally find it with respect to x, so we need to reverse what we did, okay? So we find our equation where it relates u to another variable, which is going to be here, our tangent theta equal to u. So we'll start with that. Okay, so now instead of u, I write tangent theta. So now, because we have our trig function, we need to go to this, and we look at where theta and x are related, which is at the very, very, very top, which is here. So we solve for our secant by dividing by the square root of 7, and we get secant theta is equal to x square root of 7. We use our SOHCAHTOA. Secant is the inverse of cosine, so we flip it. If cosine is a over h, that means secant is going to be h over a. So instead of x over the square root of 7, we have, you could either still say a over, sorry. So yeah, oh yeah. So instead of a over h, we now have h over a. There we go. My bad. So we draw our triangle. We have our hypotenuse, which is x, and we have our adjacent, which is the square root of 7. And we need to find our other leg. We use the Pythagorean theorem to find that leg. And then we're looking for tangent, right? That's our goal, to change this theta to our x. So we can do that now. Tangent using SOHCAHTOA is opposite over adjacent. So that's what we're going to do. Our opposite is b, which is this radical right here, divided by our adjacent, which is the square root of 7. So that's where this red part is coming from, plus c. And then we simplify it. So this square root of 7 here cancels with that square root of 7 there. And then we're left with the final answer.